when I started off my entrepreneurial journey in 2013, I was a fresh PhD from Purdue. And he was one of the first biotech folks I met, and he actually started us off and gave us all the do's and don'ts in the biotech industry. So, of course, Dr. Chandru doesn't need any introduction, but I will give it my best shot. Dr. Chandru has his formal training in electrical engineering from BITS Pilani, systems engineering UCLA, and operations research MIT. He has more than 3 decades of experience in academia and industry, a fellow of Indian Academies of Sciences and Engineering, as well as the Operational Research Society of India. He began his academic career in computational and decision sciences at Purdue between 82 to 92, before continuing at IISc in India since 1992. He has held several visiting positions at the University of Pennsylvania, IBM, Watson Research Center, MIT, and Stanford. Technology entrepreneur, he was one of the first inventors of the award-winning Simputer, and currently serves as the founder-director of Strand Life Sciences, both spin-offs from IISc. From what I understand, he was one of the first professors at IISc to actually come out of the academic institute and start his own company. Now there are many more to follow suit. Strand Life Sciences, which he led from 2001 to 17, is now India's leading precision medicine company and specialty clinical diagnostics company with 27 labs and 850 employees across India. Dr. Chandru was named a technology pioneer of the World Economic Forum in 2006 and was awarded the President's Medal of Informs the same year. In July 2018, he was appointed as a National Distinguished Technologist at the Indian Institute of Science. He serves on the Karnataka State Division Group and the Council for Science and Technology, as well as biotechnology. And of course, he's a mentor to several of us biotech entrepreneurs. So without much further ado, I'd like to invite Dr. Chandru on stage.
So, I realized that there are a number of students, many of you who were students at Purdue around the same years I was teaching there. So students are usually much smarter than professors. So I expect you to keep me straight, and hopefully will tell you some new interesting things. You know, when I was thinking about this longevity issue and health and so on, this number 164 popped into my head. Now I realize I should have said 150, since we are celebrating Purdue 150. But so really the 164 is kind of figurative. It came from the Beatles song, when I'm 64, right? So when I'm 164 now. I have this picture of Kushwant Singh, who in India is, of course, a well-loved journalist who also didn't make any excuses for his love of the drink, and he would occasionally write little poems. And so I paraphrased one of his poems to say that the horse and the mule live for 30 years and know nothing of wines and beers. But men sinful, ginful, rum-soaked to the core, survive for 80 years and 4. So 1 score is 20, so 80 years and 4 is 164. So that was me when some of you were students at Purdue. So just to remind you that it's the same me, right? I looked a little different then, but those were amazing years. And that picture is actually from Ferd Limekuller's book about the School of Industrial Engineering, which I think is, is a wonderful testament to the school. And of course, in those days, I don't know if it's still true, it was ranked as the top school in the country in industrial engineering, the US News and World Report. I think Ravi and I have T-shirts which still say #1 and so on. So it's it was great years there. So let me just start off with a little. The fact is that life expectancy in India today is just under 70 years, right? So 164 seems to be a bit of a stretch, but as you know, I don't know about, well, maybe we should take a little poll here. How many of you in the audience have a family member, reasonably close family member, who's now over the age of 90, right? So I would say about 30% of the audience sort of has that. I mean, over 80, I think almost all hands would rise. Over 80, I think, yeah, basically, yeah. So it's clear that, some people in India are certainly living to be much longer. So now the next poll is, how many of you are happy with the way things are? That is, an life expectancy of about 80 years, 80 plus years. Okay. How many of you would like to live to be 120? Right? So that's a little bit longer. How many of you would like to live to be 150? Right? So, yeah, I mean, so these polls have been conducted in many parts of the world, and I'll give you some data later on that, right? So here I think it sort of was roughly about equal. People, maybe lots of people didn't vote, so didn't raise their hands, so it's sort of not a very good poll in that sense, but we'll get back to it. It turns out that India is right now 142nd in the world in terms of longevity. In terms of life expectancy, right? And the Hong Kong has now surpassed Japan, right? Japan is about 83.9, and Hong Kong is ahead by a bit. And from the visits I've made in the last year to hospitals in China, I expect China to be in front eventually. And by the way, I just have this picture of the latest Technology Review magazine, which I think everybody should take a look at, because it's starting to look like China is dominating in almost every area of technology, right? Oops, sorry. I think the graphic is not complete here, so I'll kind of skip that. But broadly, what it was saying was that essentially, there's been kind of a singularity in terms of development, and a lot of that is just due to technology and the pace at which it's moving. And I'm going to focus a little bit on genomics, because that's the field in which I've been working now for almost 20 years. So, and genomics has actually gone through a really interesting exponential growth, very much like what we saw in electronics, right, and computing. And basically, what is also interesting is that the timelines of molecular biology, modern molecular biology, sort of coincident with the timelines of modern computing and electronics. So roughly post-World War II, you start seeing the initial breakthroughs, with Turing and von Neumann figuring out how computing is going to work, Crick and Watson figuring out the structure of DNA, and then things running more or less in parallel. Now, it actually turns out that the Moore's law, which I think we saw the impact of Moore's law in a very significant way in the previous presentation in AI, the effect of course, has been that technology capabilities have been doubling inexorably every 18 months or so in electronics, and that has essentially taken us into what is called the second half of the chessboard, right? So basically we got a factor of 2 raised to the power 32 speed up in technology around 2006, right? And in the last 10 years, we've been in the second half of the chessboard, which means that it's almost a vertical sort of takeoff, right? And that's what Kurzweil refers to as singularities, and that's the singularity that we are riding, and everything that we expect is happening 3 or 4 years sooner than we expect, right? Autonomous vehicles, all kinds of AI applications that were referred to in the previous talk and so on. But what about genomics? Genomics is actually growing even faster, right? It's going at the square of Moore's law since 2007, since the advent of next-gen sequencing. And we are now staring pretty much at being able to sequence an entire human genome at about $100 a piece. Those are the internal costs we know at places like Illumina. And so it's just a matter of time when competition forces the actual costs down to that level. And that competition has started because Beijing Genomics has announced a competitive sequencing technology to Illumina, and it was introduced about 3 months back. And so now we'll soon see prices come down. There's been a little bit of a monopoly phase that I think will soon end. So I think one has to expect that there are going to be phenomenal ability to read human genomes and be able to not just read it once, but read it multiple times to see how it changes, expression, etc. Right. We don't know quite yet, but it looks like if all of this pans out and precision medicine is allowed to play out its value, simulations run by the RAND Corporation actually indicate that there could be huge benefits in all non-communicable diseases, not just in cancer and monogenic disorders or rare diseases that we are seeing today, but this can go very, very far. The problem is that the institutional alignments have to take place in order for this to happen. And at the World Economic Forum, we actually worked on this as a paper on how to improve alignments to make some of these progress a reality. The other big development has, of course, now not just been in reading genomes, which is what we've been talking about till now, but also writing genomes. Okay? And this has been called a crack in creation by Jennifer Doudna, who actually developed the CRISPR technology at Berkeley, right? So, of course, academics are very excited about it. George Church at Harvard is actually running the human genome writing program. So they're actually going to try to write a complete human genome synthetically. And there are various experiments going on, of course. The impact is already being seen in areas like immunotherapeutics for cancer. Of course, the price points and so on are challenging. You have Novartis and Gilead now with 2 therapies in the market for various leukemias, myelomas, and they're starting to look at solid tumors. Siddharth Mukherjee was in Bangalore last month and basically pushing Indian biotech companies and so on to get involved in all of this. So it just does look like there's going to be impact. And here what happens is this is all autologous. in the sense that you take stem cells out, or T cells out in this case, you engineer the DNA in those cells and put them back. And it boosts the immune system to actually fight the cancer, right? Now, what Aditya was pointing out to me earlier was that this will actually really take off only when you can do this through donors and not just autologous, right? And that's a big challenge because of various problems of rejection by the host of cells from donors, right? There are various techniques that are coming about and companies and so on that are getting involved in these using this CRISPR-Cas9 and gene editing. And again, China, right? We all saw this in December. Suddenly, there was this announcement that Dr. He Jianxi, I think, had actually engineered a pair of twins to have genetic protection against HIV, right? And this was, for the first time, germline gene editing done in a human experiment. And of course, there was a huge reaction, and people, have been condemning him. The Chinese government has sort of put him under house arrest, but I'm pretty sure that this experiment couldn't have been carried out without tacit approval from some authorities, right? So I think definitely things are moving very fast, and these are going to have major impacts on health, longevity, etc. Right? So again, I'm taking a very genomic perspective on this. One could take other perspectives. I think Ravi and I were talking during the break about telomeres and so on. People have been looking at aging from very different perspectives. But from a genetic perspective, of course, these are the masterminds of genomics over the years. And there's a wonderful book by David Duncan, who's a Midwestern lad who now teaches at Berkeley, and he's a journalist, and he writes a lot about experimental methods in biology. And this book, Genetic Masterminds, was actually originally called the geneticist who played hoops with my DNA. And so in that, he gives these major players in genetics interesting sort of mythological names. And Cynthia Kenyon is sort of the interesting student of Sidney Brenner, who actually has increased the lifespan of animal models now tenfold, right? Of course, she did it with C. elegans, and which is the worm, and then later has worked with mice and is now starting to work on dogs, small dogs, I think. So she is, she's, supposedly got her finger now on some genetic markers, which would be the fountain of youth. Now, the interesting thing about the worm experiments and so on is that they actually, these mice don't age fast, right? They actually stay young for a long time. So it actually does seem like it's the fountain of youth, right? In discovery of the fountain of youth. Now, whether all of this will translate to human, what will be the side effects of similar experiments on humans will of course take a long time to resolve. But in principle, it doesn't seem unlikely that people could live to be 150 years, and I think AK was not wrong in being willing to take a bet on it, right? And I think in principle, it could be more like 200 years or or even more, right? And now we can talk a little bit towards the end, or maybe in the Q&A, about motivation and why would people want to live. And clearly, many of you didn't raise your hands when we asked about 150, and I will make a comment on that later, right? The real question is, if you want to stay healthy and live long, then there are many challenges to health that come along, right? Between the ages of when you're born to maybe around the age of 10, 12, first of all, you have to be born, so there is the fertilization question. Then, things like autism, hearing and vision, allergies, various types of monogenic disorders, that rare diseases that could affect. The major issues maybe in your teens and young adult years are, sports injuries, concussion, depression, diabetes, HIV, just because of unprotected sex and so on. In midlife, more and more we are seeing early diagnosis of cancer. You have challenges during the reproduction process. And of course, just things like influenza and the stresses of life causing, problems of suicide and so forth. And then, later years, neurodegenerative disorders and, and failure of organs like renal systems and cancer, again, coming back in old age is quite common now. Maybe 1 in 3 in the West, 1 in 3 people actually get diagnosed with cancer, at some stage, usually when they're older, right? And then all the metabolic diseases and cardiovascular and so on. So I think the question is the system working on fixing each of these so that, when we do live for a longer period, we are able to live a reasonably high quality of life, or we are, challenged. We survive because of tertiary sort of care that's given in hospitals and ICUs and so on, and but that isn't the quality of life. So I think let me just skip through a couple of these. We are certainly seeing, 40 years ago when the first test tube baby was born, there was, her name I think is Louisa Brown. There was this fear that we are interfering with a natural process. There was a lot of fear, right? Like we heard some fears expressed about AI and so on. There were similar fears about that. But today, I think in vitro fertilization is there almost on every block in middle-class neighborhoods, right? In India and elsewhere. So, and then techniques of, carrier screening, newborn screening, prenatal testing, and various cures for Mendelian disorders using, techniques that people like Aditya and so on are coming up with. So this is, oh, I lost another slide, but that's okay. Again, back to this question, and I'll sort of end here, is that, how long do people want to live, right? And this desired lifespan question, it turns out that most people are satisfied with where they are in these polls that have been carried out in many places. There is about 30% who wouldn't mind going to the high end of the spectrum today. we know that some of the oldest people alive are around 120 years, and maybe 10% choose to live until 150. And of course, there is a small number of people who want to live forever, right? So this, I was thinking about this, and I was listening to some talks that Cynthia Kenyon has given on longevity, and the thought that came about was that what she says, and I think it's an interesting thought, is that people now want to live long enough to see their grandchildren go to college. Okay, so there is motivation to stay healthy and be active, to help your children take care of their children and get them all the way to college, and after that, basically you're done, right? And that puts you in that 80 to 90 age category, at least in the West, and perhaps in India that happens a little sooner. I have a 4-year-old granddaughter, so I think I still have to keep going for another 15 years or so, but that would put me at about 80. So that's about right. And beyond that, there isn't a strong motivation yet in our, to keep going. So that's a really interesting thought. And why would people want to live longer? Because you can. I mean, fundamentally, science and technology are telling us that you can, but the question is, do you want to, and why would you want to, right? I just want to end with this dedication to my dad, who was 91 years old, and he was still playing golf, and he actually won the Seniors Cup at the Bangalore Golf Club at 91 with a hole-in-one, right? And so he's been the inspiration, in some sense, for this lecture. But also, I think he passed away 3 years after that, just when the youngest grandchild went to college, right? So it was an interesting coincidence, but my youngest sister's son went to Northwestern, so I think he was done at that point. But there were other reasons, of course, medical reasons and so on, but it is an interesting note to end on. Right, thank you.
So thank you, Dr. Chandru, for the wonderful talk about longevity and aging. And I, for sure, want to live up to 160, 170,
okay,
or maybe more if possible. I don't know about most of the audience. You did speak about motivations earlier, but I have a question about accessibility, because we do know that those that live up to 110 or 115 are few and probably genetic anomalies. Most of us would require a pharmaceutical intervention,
Right.
but as we know, those are expensive. I mean, you spoke about Yescarta and Kymria. They cost upwards of $1 million. Right? You can cure genetic blindness, but that costs upwards of $1 million. So also immunotherapy,
Right.
$200,000. So it's not really accessible to most people. So what are your thoughts on that?
No, absolutely. And I think, the hope, of course, is that, at the stage of innovation of many of these technologies, you're going to see those high prices. And then eventually there will be, some ways to bring those down. I mean, think about, I think, the Gilead model and Sovaldi, right? Where essentially it was priced at $84,000 for initially in the U.S. market and in Western markets, and then there was a graded pricing, and eventually they licensed pharmaceutical companies in India to manufacture it as a generic and sell it at generic prices, where today in India for maybe 20 or 30,000 rupees you can clear hepatitis C, which would have been a massive killer otherwise, right? So I think there are sort of ways in which these margins that are built into the pricing of these therapies can actually work out. There's obviously a lot of complexity to this, but for example, a lot of these gene therapies or cell-based therapies that we're talking about, which you're pricing, you were pointing out, are priced at $1 million. If you actually look at the cost-plus model, right? The cost-plus model is really not very much more than a bone marrow transplant. And a bone marrow transplant today in a government hospital or a charitable hospital like CMC Vellore is done at between 3 to 5 lakhs, or in a private hospital maybe at about 10 lakhs to 15 lakhs. So $1 million and 10 to 15 lakhs. There's a lot of room there, and I do believe that eventually there may be ways in which we can actually bring the prices of these treatments down and make them more accessible. And so I think it's not short term, but I think they.
So great point there, Dr. Chandru.
Right.
And the Hep C model, the Sovaldi model is of course a classic example.
Right.
But as we know, Gilead is a big corporation, and
Sure.
developing countries in general have a larger population of patients, so they did still make money.
Right.
But I'm talking about, for example, Calico, which is
Yeah.
one of the first companies that entered the aging game.
Right.
Google pumped in more than $1 billion to set it up. In the last 1 week, there have been 2 biotech companies in the US that just got off $100+ million Series A's.
Mm-hmm.
Now, all these are bankers and venture capitalists putting in money. There's Google
Right.
putting in money. So, how do you think they're going to make the money back?
No,
if
no.
they start selling
So
their
they will
aging
make the
drugs?
money back. I'm not saying they won't make the money back. They just won't make the money back multiple times over, right? So I think those balances have to be worked out, and societies have to figure out what is reasonable. I do think So, for example, we work at Strand on early detection of cancer using liquid biopsies, right? So we know that in something like 3 to 5 years, we're all going to be in a situation where an annual blood test will tell you that there is an early stages of cancer in the body, and you can actually treat it and manage it, because this will be at stage 1 or stage 2 of cancer, and you'll be able to manage it. But the companies that are developing this are, like Grail, again, Google was involved, and they have raised close to $1 billion in their Series B. So naturally, the pricing is going to be worked out so that there's a recovery of that investment. In India, we are doing it in a much more capital effective way, right? So there's a possibility that these innovations will come now from countries like India and China, where we actually have to price things appropriately, and also since it'll be done much more capital efficiently, the pricing models can vary. The health economics will be very, very different in China and India, I think. Right? And also the whole focus on preventive and early detection of illness and health problems will have to be the focus of health care in these large population countries.
Thanks. So your point on preventive is well taken. Actually, that brings me to my next question.
Sure.
Because while we speak about pharmaceutical interventions, there are a bunch of academic institutes, Harvard, University of South Florida, which are actually doing a lot of research on things like restricted time feeding, intermittent fasting, and
Sure.
they're claiming the same thing in animal models, that if you stick to a 16-hour fasting window and 8-hour eating window, and so on, they've seen the lifespan of mice double.
Right.
And they are also reporting the same in bigger animals, and also in small clinical trials.
Right.
So what are your thoughts on
Oh, absolutely.
this aspect versus pharmaceutical?
I think, particularly, metabolic diseases like diabetes, I think it's very clear that behavioral changes are going to make a big difference. So Strand is actually now working with a global payer, an insurance company, which has interest in trying to reverse the effects of pre-diabetes, right? So can you actually get someone who's pre-diabetic back into the normal zone? That is somewhere between a 6 and a 7 HbA1c back to below 6, right? How do you do that? And the technique being used is that there are continuous glucose monitoring systems put on these individuals, and Fitbits and various data being recorded, and the cohort size is about 10,000 right now. So it's being done on a very large study, and intermittent fasting is starting to show excellent results, right, for reversal of pre-diabetics. And this could be like 16-hour fasts, maybe twice a week, or 24-hour fasts if you want to, get it working much faster. Plus, you're monitoring exercise, monitoring when you take your metformin or whatever meds, at what time relative to when you eat, and from these experiments, I think there's definitely going to be new strategies, and payers are interested because, finally their insurance margins are going to improve if people take better care of themselves. Right? So it's kind of interesting.
Thank you. I'm glad you brought up metformin because a recent study shows that it binds to mTOR.
Right.
And they have seen life expectancy increase. So all the diabetics taking metformin regularly may be living 20 years longer.
Right.
So I don't want to hog all the time today, and I'd like to open up the floor for questions from the audience.
Sure.
Hi guys, I'm Udesh. I graduated at Purdue in 2015 in electrical and computer engineering technology. I'm glad you brought up intermittent fasting and metformin and metabolic therapies for things like cancer, especially. There's a lot of research being done in metabolic therapies for that, and especially that type 2 diabetes, which is one of the biggest problems we have in this region. Sure. Like, I'm from Colombo in Sri Lanka, and it's terrible. Like, I'm driving to work every morning, I see at least maybe 2 or 3 people with their legs just completely wrecked by the disease. And I've been practicing intermittent fasting for years now. I did a 1-week fast recently, coming up on another one soon. My issue is, like, it's hard to patent eat well and exercise. Sure. Like, yeah. There's definitely a difference between health span and lifespan, right? And a lot of people here were concerned, like, I don't really want to live that long because I don't want the knee pain, and I don't want the back pain, and I don't want the shoulder injuries to exist. But there's definitely something to be said for being healthier longer instead of just trying to live longer. And why do you, like, in your opinion, in my opinion at least, there's a lot that we could be doing to make the 8 years we have right now be much more productive, much more healthy. In your opinion, do you think that the genetic and the pharmaceutical interventions should be given more precedent, Or do you think that there's still a lot we can do right now by just addressing our diet, our exercise? I mean, we know for example.
Yeah, I think, I get the question. I think the challenge with behavioral modification is compliance, right? I think, most people will not comply with behavioral modification. Look at smoking, right? And what impact have we had on getting people to stop smoking with all those horrible images that are put in movie theaters and on the boxes of cigarette cartons and so on? How many people actually give up? And in what class of society and what gender? And the sort of nudge mechanisms to actually get people to change behavior is a very, very complex problem, right? Now, on the other hand, if an insurance company tells you that they're going to actually change your premium, okay, based on how you behave yourself, right? Maybe there is an opportunity there, right? Now, for example, I'm on a plan with Apollo Munich, which actually tells me that they'll measure me every 3 months, and if I've kept my weight down, my HbA1c numbers are good, then they'll actually reimburse 15% of the premium that I pay. Okay, so now that's an interesting plan, and it's actually forced me to do a few things that maybe I would have been reluctant to do in terms of everyday sort of activity and so on. So I do think one has to work out the alignments and how these nudge mechanisms will work to really make these preventive strategies work properly. But I think it's a challenge. It's a challenge to get people to change their behavior. Right?
Thank you. We have another question here.
You came up with a nice statistics, and you found in India. Was that statistic from India or all over? That age, life expectancy and all this one, 80 years, 120 years, 100.
No, that's a global.
Global.
Yeah.
But you did it
It's
with
mostly a Western study.
but you did it, explained it in the Indian context. Why does 60% of the people want to live only 80? Because you related it to, till then they can take care of their grandchildren. And what does it mean? If you were to ask that same questions now in the Indian context differently and say, look here, till 80, you are active with the genome technology and all this, you are active till 80, but you still can have 100 or 120, you can still remain active till 100 for the benefit of the society.
Right.
Yeah? So if you give them an option of being healthy and productively busy, I think people will like to live as long as they can.
Sure.
Not restricted that to the 100 or 120. Second thing, in addition to that...
So you fall in the 30%.
Pardon?
Right. So you fall in the 30%. Right.
I'm talking even of
Right.
1%.
Right.
Yeah?
Sure.
I will even go further and ask you, to this if you club that at 80, you will have such a good willpower, and that willpower can take you to 120. Would you like to do it? I think many people will say yes.
Yeah.
Because after a certain age, even at my 82, it is the willpower that is taking me more than my health. Thank you.
Right. No, absolutely. And I think all these factors play a role. And I think all that I was trying to point out was that I think what we don't really have in our social models right now is what is going to happen beyond that stage of taking care of grandchildren or whatever. What is the kind of service you want to do, or how do you want to live after that? So, as my friend David Duncan says, will you still feed me? Will you still need me when I'm 164? But then remember that you'll be 160 as well, right? So there is that issue of how the social systems are going to work, and and there is, of course, the whole support mechanism of your family and how what will be the motivation. I mean, there is, of course, the basic affection of family and so on to keep taking care of people. But I think it's a complex question, and I think we have to find ways of, even everything that we've thought of in our minds about retirement, till when we work, the nest eggs, how we're going to plan our retirement. All of those things would have to be re-examined, and already are being re-examined. In India, I'm at the age of 65, I was told by the university, you are now, superannuated, right? That's the term we use. And so, unless you get some kind of a special chair or something like that to continue as an emeritus, you have no role left in academia. Of course, you could go to private colleges and so on and teach, but there's lots of complexity to this on how economically people will sustain if they live that much longer, and we already are facing that, and we, I think as society, we have to look at these more carefully.
We have time for one more
One
question.
more? Yeah, sure.
Yeah, good afternoon. I am Srividya from Dr. Reddy's. Thank you for a very interesting talk on how genomics has also progressed in the last decade. So in the next decade, what do you see coming up as breakthroughs, and also in terms of personalized medicine? Do you think that's something that's really going to take off in the next decade, and what is the potential that you see for that?
Yeah, I think the potential is huge. It's and I think genomics was only the first phase of just reading DNA. We're already now into single cell RNA sequencing, and so we're starting to see a little more. Eventually, of course, health. A lot of the health profile comes from being able to look at the cellular level. So, when people talk about, being able to move from genome to transcriptome to proteome to cellome, so cellome is probably where you'll start seeing some serious impact into precision medicine and personalized medicine. We're not that far away from it. I think the Broad Institute has started a huge cell mapping project, and I think we will see the impact of that maybe in the next 5 to 10 years. It's so I think that direction is certainly in which things are progressing. But I think as I showed, the simulation model run by the RAND Corporation, the author of that paper was actually the president of the Institute of Medicine, Victor Zhao, and it's a very telling sort of picture that actually shows that if precision medicine actually permeates all of healthcare in a substantive way, there could be a huge impact, right? And I think we can see that. There's one more hand raised, but
let's ask a really short question. Go ahead.
Right, sure.
So I just need your thoughts on in the next decade or so, is the life expectancy going to increase? Because a lot of new diseases are getting discovered, pollution is there, the vectors are increasing, superbugs and a lot of things. So what do you think, as for is there any research being done on that? Like if we talk about
I don't
India,
know,
China.
Melinda Gates just made a statement, right, that the world's health is improving, right? So no, but seriously, I think there are challenges, but our interventions are also much stronger now. But unless we obviously take care of our environment and so on, there could be some very
So we
serious
need to plan
consequences.
till 120 or something, retirement. So that's what I was worried about actually.
Well, I think 120 is already been reached, right? The oldest recorded sort of oldest person is 122. The lady in France, I think Jean something. So I think 120 has been breached. Now, whether the median will move up closer to that is the question. Right?
Very good. Well,
Thank you.
Right, sure.
thank you very much, Vijay, Aditya.
Thanks.